Hello everyone, welcome to Greenboard Academy. I'm your instructor Jai Sukhwani. So in the previous video, we have discussed about a plane mirror, that how you can see your image in plane mirror. So now in the next topic, we are coming to the curved mirrors. Before that, I want to say one thing, that as in the previous video, I have said that in the slides there will be some facts about light. Here also in the slides there will be some facts about light. So check it out and list it out properly. So before discussing about a curved surface, let's take an example of a spoon. You can see the two different sides of a spoon. One is the back side, which is the first image, and second is the front side, which is the second image. This curved surface of back side of spoon and front side of spoon is known as curved surface. From this, one side is concave and second side is convex. We have discussed about concave and convex mirror in 9th standard. So now I will put this on you, that which side of spoon is concave mirror and which side of spoon is convex mirror. Just think about it. Now we will discuss about spherical mirror. Now the spherical mirror are the most used curved mirror. Means spherical mirror are also curved mirror and they are mostly used. But before that, we should know one thing, that what is spherical mirror. Now the mirror whose reflecting side is spherical in shape are known as spherical mirrors. But what is reflecting side? In the previous video, we have discussed about a surface on which incident ray comes and reflected rays go. So the surface on which this all happens is a reflecting surface. And if this reflecting surface is spherical in shape, means rounded in shape, are known as spherical mirrors. Now we will discuss about the spherical mirrors in detail. Before that, we can take one example of a disco ball. You can see in the image, the disco ball is having small mirrors on its surface. They all are spherical mirror. They reflect the light all over the club and you can enjoy the lighting due to this disco ball. I hope you understood that how spherical mirrors work. As I have discussed in the previous slide, that spherical mirror can have reflecting surface either inwards or outwards. We have seen that thing in the spoon. When you see the back side of a spoon, the reflecting surface is outwards. And when you see the front side of a spoon, the reflecting surface is inwards. And if the reflecting surface is inwards, then it is known as a concave mirror. So we can say that front side of a spoon is concave mirror. And if the reflecting surface is outwards, then it is known as a convex mirror. So we can say that back side of a spoon is a convex mirror. You can see in the image, the reflecting surface is outside. That's why it is known as convex mirror. And if the reflecting surface is inside, then it is known as a concave mirror. So I have told you to decide which part of spoon is concave mirror and which part of spoon is convex mirror. So now you understood that the back side of a spoon, where the reflecting surface is outwards, is convex mirror, and the front side of a spoon whose reflecting surface is inwards is concave mirror. Now let's see in the next slide. So we can see in the spoon, the front side of a spoon, this side, this one, It is a front side of a spoon, and it is a concave mirror, and this is a back side of a spoon, which is convex mirror. So we have a difference between concave and convex mirror. The first difference is, in the concave mirror, the reflecting side is inwards, and in the convex mirror, the reflecting side is outwards. Now, the second difference you can spot in the spoon. In the first image, you can see the image is inverted. This is me holding the phone, and my image came is inverted, means legs are up and head is down. So when the image is inverted, it is concave mirror. And you can see in the second image, my head is there and I am holding a phone, so the image is straight. So we can say in the convex mirror, the image is straight. So we got the two differences of concave and convex mirror. Now we will discuss about a spherical mirror in detail. So you can see here, this is a mirror, a spherical mirror, right? A spherical mirror is part of a sphere or a circle, right? So first of all, we will discuss some points of spherical mirror. First is pole. What is pole? You can see the point P here. So we can say the center of the reflecting part. This is the reflecting part because this is a spherical mirror. So the center of the reflecting part is known as pole. Understood? Now second is center of curvature. So you can see this spherical mirror is part of a circle, right? So there will be diameter, radius and all the things, right? And center of the circle also. So the center of this circle is known as center of curvature. You can see here, this is circle and this is center. The C point is given, which is known as center of curvature. Now what is radius of curvature? So you can see point C and point P, right? So you know the definition of radius. What is radius? Radius is a line segment whose one end point is center of circle and another end point is on the circle, right? So here also C, center of curvature, is center of the circle, and the second point P, which is on the circle. So we can say CP is a radius. So the distance between C and P is known as radius, or we can say the distance between center of curvature and pole is known as radius of curvature. Next is principal axis. So you can see a line passing through center of curvature and a pole is known as principal axis. It always passes from center of curvature and pole. So I have done one experiment related to mirror. So how this happens? We have seen some experiment with the magnifying lens in our childhood. That when we keep the magnifying lens in the sun and under it we keep one paper, then due to sunlight the paper will burn. So let's check it out. So I have taken one paper and one mirror. I am concentrating sunlight to one point on the paper. So you can see one thing, the sunlight is passing through the mirror and focusing on one point, on a single point, and that single point has started burning. You can see the smoke coming out of it. So how this happens? We'll understand this thing in detail. I have tried to burn the paper, but due to the wind, not able to. You can see the wind behind the. You can see a big hole I made with the help of a lens and sunlight. So you can see this big hole. But how the paper burnt? There should be some reason behind it, right? So what does the lens do? When the sunlight is passing through the lens reflect and concentrates on one point, that is a bright spot, or you can say burning point. It concentrates on one point, and due to this reflection, paper starts burning. But this is possible only in concave lens, not convex lens. Why? We will see the reason. But first of all, see the image. A sunlight is coming from somewhere, passing from the lens and concentrating on one matchstick. It ignites and the thread is. So I hope you understood this. Next, we will understand this thing with the help of a ray diagram. So you can see the rays are coming from the sun, which are coming on lens and reflecting and pointing on one point, that is known as principal focus and symbolized with F. And this happens only in concave mirror. Now let's see what happens in the convex mirror. When the rays are coming from the sun, it comes on the lens, reflects and goes on in the different sides, and they can't meet in the real world. You can see here the lens are going in a different direction, and it is not possible for them to meet in the real world. So they meet virtually behind the mirror. You can see here. You can see here the dotted lines. Now they are focusing on one point, that is known as principal focus, denoted by small f. Now let's understand this formula. R equals to 2f. Now R is a radius, C is center of curvature, P is pole, F is focus, and small f is focal length. We will see all this thing in a diagram. Now you can see CP. CP is radius of curvature, right? Now this point C is center of curvature. Now this line is passing through the center, that is known as principal axis. A center on the reflected surface is known as pole, right? So now what is Mn? Mn is an aperture. Now what is this aperture? Now as we have seen, the center of the circle came, radius came. So we can say one thing, that Mn is a diameter. It passes from the center and it is known as the longest chord of circle. So Mn is a diameter, and diameter is always double of radius. So Mn equals to 2r. I have written here. Now what is Fp? Fp is known as focal length, means distance between principal focus and pole. Now what is MC? This part. Cn means this, and Cp means this. What are these three? So we can say these are the radius of a circle. Now Fp is half of Cp. This Fp is half of whole Cp. 2 is in division, so it will go in multiplication. Here you can see 2 is in denominator, so it will surely go in numerator and get multiplied. So 2 Fp equals to Cp, right? So what is Fp? Fp is a focal length denoted by small f. So instead of Fp, we will keep small f. So 2f equals to, what is Cp? Cp is radius of curvature, means r. So from that we get a formula, r equals to 2a. I hope you understood this. If this video made easy for you to understand each and every point, then please like and share this video, because it is very necessary that this video reaches each and every person who needs proper explanation. So I hope you will share as much as you can, and don't forget to subscribe my channel. Thank you.